So we are dealing with the 19th problem in this series, and the 19th problem in this series is problem number 1.136. The problem is stating a small body A starts sliding from a height h down an inclined groove, passing into a half circle of radius h by 2. Assuming the friction to be negligible, find the velocity of the body at the highest point of its trajectory after breaking off the groove. So as we approach this problem, we will need a diagram of our own. So let us begin by drawing the diagram. So now this is the situation which is given in the problem. Now for a block which will be reaching here, the small mass or the particle which will be reaching here at the lowest point of the trajectory, falling from a height h, it will attain a speed which we refer as root 2 gh. Now it will be moving in a circular path of radius h by 2. So to complete vertical circular motion, the minimum speed needed is equal to root 5 gr. So if we think in this term, so we have 5g, r being equal to h by 2, and over here we have speed root 2 g h. So this is greater than root 2 gh, it is 2.5 gh. So the minimum speed is not reached. So we can say over here u is less than u minimum, and hence the particle will not cover complete circle. So now what is going to happen is maybe if we consider this one as a point P, so at the point P it will break off from this circular trajectory and start moving in a parabolic path, and at the highest point we are supposed to calculate the speed of the particle. So in order to begin understanding this, let us move to this another diagram that we have. So at this point it is having a speed u, and at this point, say point P, where it just break off from this circular path, and it will start moving in a parabolic trajectory like this, and it will join somewhere here if there is a track, and we are asked to calculate the velocity at this highest point. So if this is 90 degree, this angle is theta. So over here if we join this up, we can say that this angle is 90 degree, 90 minus theta, again theta. So over here we have this one as 90 minus theta, and at the highest point the horizontal component of the speed will remain unchanged in the projectile motion. So it is v cos of 90 minus theta, which we write as v sin theta. So now the idea is to determine this speed v when it is breaking off this circular track and the angle theta. So if we start approaching to solve this approach, so we say over here that at this point the weight mg is in the downward direction. There is a component of its weight in this direction which we mark as mg sin theta, and if this force, which is mv square by r, is greater than mg sin theta or just becomes equal, then it will leave contact at point P. So therefore over here we equate them up. So at point P we say mv square by r is equal to mg sin theta, and we have an expression between v and sin theta. So we can write over here that v square equals rg sine theta. So this is the first expression that we have. Now for the second aspect, we can simple consider that we will be applying energy conservation between point A and P. So if we apply energy conservation, then we can say total energy at A is equal to total energy at point P, and we are considering A as the reference level. So at A, the energy is equal to half mu square. At P, energy is half mv square, and we will also have potential energy. So this is radius r, and this is r sine theta. So mg r plus r sine theta. So over here on solving this aspect, so over here we obtain, so if we cancel out all the m and we put v square equal to rg sine theta, so we get u square equals, so v square can be written as gr sine theta, and we are left with 2gr plus 2gr sine theta. So this is the expression that we have. Now over here, if we put the value of u as root 2gh, so root 2gh square is equal to 2gh, which is equal to g. R is equal to h by 2 sine theta plus 2g. Again r is equal to h by 2 plus 2g h by 2 sine theta. And hence if we solve this expression for sine theta, we get sine theta equals 2 by 3. So now the problem is asking us the velocity at the highest point. We have already discussed that velocity at highest point is going to be v sine theta. So we write hence velocity at highest point, which is going to be v sine theta. So for v, we put root over gr sine theta. So root over gr sine theta is equal to 2 by 3. So v can be written as gr sine theta root over, and again we have sine theta term. So g is equal to h by 2, g h by 2, sine theta is 2 by 3, root over times 2 by 3. So over here on solving, we obtain 2 by 3 root gh by 3. Root gh by 3. So this is the required answer for this particular problem that we have solved. Problem number 1.136, which is also the 19th problem in this series.